Hello all. So in this ray optic series, we have seen about refraction, then total reflection, then we have seen refraction at refracting surfaces. So two formula we have seen, rarer to denser and denser to rarer. These two formulae we are going to use now in the derivation of lens maker's formula. Now what is a lens? Lens is nothing but it is bounded by refracting surfaces. So convex lens here we are going to see, which is bounded by two convex refracting surface. So one surface is xp1y and another is xp2y. And the convex lens, double convex lens, we just say convex lens is formed by two convex refracting surfaces. Now we are going to see the lens maker's formula. For that, just see what are these terms. As this is two refracting surfaces, okay, we have P1 pole of this surface as this is center of curvature of that surface. For the other surface xp2y, P2 is the pole and C2 is center of curvature. C is called as the optical center. Now O is a point object. So first we are going to see what happens, how the final image is formed. First it is formed by xp1y and then we will consider xp2y step by step. So let us first start. Consider xp1y as the refracting surface. O is the object. So what happens, the one ray which is going along this principal axis will go straight, that is along OP1 will go straight. The ray OA will get refracted by the surface and it will go along AB. Now we are going to consider for time being that if there is no other surface xp2y, only there is xp1y and it is continuous in this side. So the refracted AB, it will go straight, see the dotted line, it will go straight and meet this ray along OP1 at I1. So I1 is the image formed, but not the final image. It is formed by the surface xp1y by the point object O. It is a real image of the object O. Yes, so we just considered now ki xp1, there is a refraction taking place at xp1 surface and it is continuous. There is no xp2y surface. So for that, this is nothing but rarer to denser. We have already derived that formula for refraction from the rarer to denser at a convex refracting surface. So that formula is mu1 by minus u plus mu2 by v equals to mu2 minus mu1 by r. So where mu1 is the rarer medium, refractive index of rarer medium, mu2 is the refractive index of the denser medium. Now here in this case we are going to apply this formula. Here you can see that the object distance is u, but image is formed as I1. So the image distance is V1. So V is V1 here. And here we are considering xp1y having radius of curvature R1. So R is R1. So I write this formula mu1 by minus u plus mu2 by V1 equals to mu2 minus mu1 by R1 as equation 1. Yeah. Now but the lens material xp1y is not continuous. There is another refracting surface xp2y. So now there is a refraction taking place at xp2y. So the ray actually doesn't go as is dotted, but it will go and meet the initial ray at I. So final image is I of the object O. For which, now for the refraction at xp2y surface, this I1 image which is formed by xp1y acts as a virtual object. So here the object distance won't be u, object distance will be v1. So this acts as a virtual object for the surface xp2y, and then the image is formed as R, which is a final image of the object O. So we will now apply this is now the refraction from denser to rarer. We'll apply the formula for denser to rarer at convex refracting surface xp2y. So now for refraction at xp2y surface, I1 acts as a virtual object and I is the image form. Then we have a formula. This is now refraction from denser to rarer medium. Denser to rarer. So we use this formula, minus mu2 by u plus mu1 by v equals to mu1 minus mu2 by r. So in this case, u is nothing but object distance, which is v1, and radius of curvature is r2. So you get the equation minus mu2 by v1 plus mu1 by v equals to mu1 minus mu2 by r2. That is equation 2. So we have two equations now. Rarer to denser, that formula we got, equation 1, and equation 2 for denser to rarer medium. Now we are going to add these two equations. So adding 1 and 2. So you can see here, if you add this mu2 by v1 and minus mu2 by v1 will get cancelled. So we have mu1 by minus u plus mu1 by v equals to, I can take common mu2 minus mu1 in the bracket. Here it will be 1 by r1, and as it is here mu1 minus mu2, now it will become minus, so minus 1 by r2. I will take mu1 common. Shifting the mu1 to the other side. So we have shifted the mu1 to the other side, so we get mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. Now we are going to consider that when the object is at infinity, that is when u is infinity, you know that image is formed at focus, that is v is f focal length. So we have 1 by f minus 1 by infinity, this side as it is. 1 by infinity is 0. So we have 1 by f equals to mu2 by mu1 minus 1, 1 by r1 minus 1 by r2. Now mu2 by mu1, you know that it is a refractive index of 2 with respective 1. This is the surrounding medium. So that is 1 by f equals to mu2 1 minus 1, 1 by r1 minus 1 by r2. This is the lens maker's formula.